Hello, good evening, guys. In this YouTube video, we'll be discussing about the circular queues, and we'll be performing operations on circular queue as a CQ, I mean insertion of elements, and DQ, deletion of elements from the queue, and then displaying all the elements present in a circular queue. Okay, let's move. Before move on to the circular queue, we'll discuss what is a linear queue and what is a circular queue. Okay, the major three differences present in a linear queue and circular queue is here in circular queue, memory utilization is very efficient when compared to linear queue. I mean, the data is not get wasted. And the second is here, the last elements present in a linear queue is attached to the first element. That makes it the circular queue. It is also a linear data structure. I mean, the elements are present in linear form, but the last element is connected to the first element that makes it circular. And the third point is in linear queue the insertion of elements should be always at the rear and the deletion of elements always at the front, but in circular queue there is no such rule. I mean, we can delete and insert elements at any position. And coming to last point, and here in linear queue it follows a FIFO rule. I mean, whenever the element is first inserted, should be first popped out. I mean, it should be deleted first. For example, in linear queue 10 is inserted first, right? So it will be deleted first. Such rule is called as FIFO rule. But in circular queue there is no such rule. I mean, there is no order for such that execution. Okay, this is the basic definition of circular queue, and we'll look on how we are going to perform the actions on a circular queue. Okay, let's move on to a coding part. Here we are going to use dev C++. First, before entering into the coding, we are going to define the circular queue with an I mean global size, and in that we are going to insert the elements. Okay, hash include will be our output library. Will make it more clear. Okay, here hash defined size would be, for example, we are going to take 5, and here we are taking queue of, here we are taking circular queue, right? So it is better to write circular queue of size and then integer of, and front and rear is always -1 at the starting position, so we'll simply write enter rear equals to also -1 and int I. Okay, these are the main we have to declare the in the form of, I mean, starting we have to declare in the form of global. After that we are going to define the function names. For example, cq our function name, and then void dq our will be deletion of elements. Dq, I mean cdq will be of, because we are performing circular queue, right? Cdq, and then we'll simply display. Okay, here we are I mean, we have defined three different functions, right? I mean, that we are going to use in a program. Okay, let's move on to main part. Int main is not a problem, you can use anything. Here with the help of value we are going to take options from user, and then with the help of options in switch case we are going to perform the actions. Okay, let's while one. I hope you guys remember in a stack or circular queue video I have tell what is while one. I mean, it will repeat until the end of an execution loop. I mean, whenever the loop is terminated, until then it will run it. Okay, after that we are going to write the options that user has to take. First will be cq, and then second will be dq, cdq. uh, dq, c nq. Nq will be entering of elements, right? C nq, I mean, it will be more appropriate. C dq, c nq. Perfect. and then let's move on to display part. And if you want to, okay, that's it. Let's put 10 slash in here. Okay, let's read the element. Scanf percentage d comma ampersand option. Okay, reading of elements also completed. With the help of switch case, we are going to perform this. Okay, switch of option. Whenever we are going to take an option, we are taking into three different cases. First will be CNQ. Okay, after this function, we have to simply break it because we don't want to make our case into another second case. So we'll be creating new case with circular DQ, and then we'll simply break this case also after the execution part. And then in the case 3, we'll simply display the elements in a circular queue. Okay, that's it. If the person chooses more than another 3 option, then we'll simply print as wrong option, wrong option. That's it. Okay, our main function has been completed. Okay, user takes, if for example user takes 1, and we have to write it a void cnq function. Okay guys, uh, this is a little bit lengthy program when compared to simple queues, because it has different conditions, right, when compared to a simple queue. So I'll be explaining here a little bit. So before entering into the elements, we have to check if a queue is full or not. I mean, if a queue is full, then we can't insert more elements, right? It will be the full size. So for knowing that, to know the size is full of a queue, we have to check three different conditions. So first, we know that rare, this is a rare. I mean, rare will be pointing always at the uh, I mean, if a queue is full, then rail will be pointing at size minus 1. So for first condition is if rail double equals to size minus 1, and here we have circular queue, right? Here this is our front. Okay, and for example this is our yes, this is our rail. So if front double equals to 0 and rear double equals to size minus 1, this is our queue is full, right? This is simply basic knowledge we know from linear queue. But here another condition has been added, because if front double equals to rear plus 1, I mean whenever the element is been, I mean for example f is here, for example front is here. Okay, let me delete this. Okay, if our friend is here, if you want to insert one more element, then rear would become here, right? So our rear would become here. So we can't say that. So in this position also our queue is full, right? So we can write, right, we can write as front equals to rear plus 1. This is also a condition for circular queue is full. So we'll mix three of this condition and write for circular queue which is full. Okay, but before that, let's take a inserting element, a element. Okay, let's check if first rate double equals to size minus 1 is the first condition, and then we are checking if our front double equals to 0. If it is also 0, then we can simply say that our queue is full. And then we are checking our final condition if front double equals to rear plus 1. These are the three major conditions that defines our queue is full or not. Okay, if this is true, then we have to print like the queue is full, circular queue is full. We can't add more elements. That's it. uh, After that we are going to check another two more conditions. I mean, if our rear is present it here, I mean if rear double equals to size minus 1 and our front is here, so we have to simply make rear equals to 0 and insert the element at the position of rear, right? So that's our second condition. Else if our rear double equals to size minus 1. Then we have to print like rare, sorry, queue of rare. Okay. One more thing, whenever at the point of insertion we are going to use rare, whenever the deletion we are going to use front. This is a basic concept, we all know that. Okay, here cq of cnq of rare equals to I element. Okay, our elements has been, before that we have to take the element from your user, right? Okay, scan of percentage d ampersand I element. Okay, it would be fine if we are going to ask user enter the insertion element, enter the insertion element. Okay, so we are going to get the I element, so we are simply inserting at the rare equals to, sorry, here we are going to take the rare equals to 0, and then we are inserting the q of rare equals to I element. Okay, this is fine. If there is an another condition, for example, if I say that front and rear are only at a single position, so we have to increase the rear and we have to add the element, right? So that would be our third condition. Else if rear double equals to minus 1 and front double equals to minus 1, this is a second condition, right? If there are no elements, we have to simply write rear equals to 0 and as well as front equals to 0, and we have to insert element always at the position of rear, right? So that's what cnq will be, cnq of rear will be I element. That's it, simple. After that we are going for the last condition. I mean, for example, if our rear is here, I mean, for example, if our rear is here, let me delete this. Okay, I'm saying that my rear is here, so there is no condition, right? And my front is here, and there are no elements here, so I'll simply increase the rear by a rear plus 1 and simply and then I'll increase the rear. Okay, and then cq cnq cnq of rear equals to, first I'll be increasing the rear and then cq of rear equals to I element. Okay, so this is a part for our insertion of elements in a circular cube. Okay, let's move on to a deletion. Void d cdq. I hope spelling is correct. cdq dq. Okay, perfect. Okay. Before deleting the element, we all know that from the linear queue, we have to check if there are elements. I mean, if there are elements present or not. I mean, if there are no elements present in our circular queue, we cannot delete the elements, right? So we are first checking if our elements are present or not. For that, we are simply checking if front double equals to minus 1 and rear double equals to minus, same condition as a linear queue. So there is no difference here for checking of like elements present or not. This is the basic condition and the major condition. And our friend double equals to minus 1, then we'll simply print as no elements in a queue. Circular queue will be more. Okay, okay, let me take enter d element. Okay, after that, okay, first we have checked if our elements present in our circular queue or not. Okay, if there are no elements present, it will print this. I mean, if there are elements present here and there, so we'll again check if our front equals to rear equals to -1. Only if we are having only 10, for example, take this, your front and rear would be pointing it only here. So if front double equals to rear double equals, if front double equals to rear, for example, if this is our condition, then I'll simply delete the element and make the front to the next part. I mean, I'll take it to the next, right? So I'll be writing as else if front double equals to rear, what I'll do is d element, my d element would be cq of front, cq of front, and then I'll be increasing the uh, there are two conditions. I mean, I can increase or decrease, and because if I are having the element at the first position, I can increase, but here for the first position I'll simply write as, I mean, if q is only at position, I'll simply delete this element and make front and rear equals to -1, because this is our only element, right? So our front equals to rear equals to -1. If not that, for example, consider if our element is present here. Okay, for example, I'm having element 30 here. So what I'll be doing, I'll be deleting this and I'll be increasing front to front plus plus. Simple. So the element would be CQ of front, and front is plus plus. Okay. To know which elements have been deleted, for clear understanding, the deleted element is percentage d comma d element. Slash n would be more accurate. I'll be simply taking this line and printing here. Okay, these are the three major conditions for deletion of element in a queue. Okay, everything is perfect. Let's move on to our printing or display. And unlike a linear queue, this is a little bit different because we have in a circular pattern, right? We cannot simply write, for example, for I equals to 0 to I less than size -1, print all the elements present in a linear queue. Because if you are going to write like that for 0 to and 50, so there will be, for example, if a front is here, I mean, only we have to start from the base position, right? For example, if a rear is present here, so this, the elements that are present after the, for example, a rear makes a full rotation, then that elements would be not printed. So for that we are going to check for if our front is less than or equals to rear. I mean, if this condition is true, I mean, front is here only and for example rear is here, so we'll be printing for I equals to 0 to rear, then all the elements will be included in this, right? So if front double equals to rear, for I equals to 0, I less than or equals to rear, I equals to front would be more perfect. Let me check. Okay, because from front to rear we are going to simply print it, each and every element. Printf percentage d slash n cq of I. Okay, if this condition is true, we are printing that. If our condition is false, I mean, front is here and our rear position is other position. For example, uh, we can say that our rear is here and our front is here. Okay, let me delete this, and the front is here. So how we are going to print this? So first, for 0 to, I mean, 0 to rear, we are going to print and remaining elements from it. For example, uh, for front to rear, I mean whatever the elements present from front to rear, I mean size, we are going to print that. So first 0 to rear, and then for I equals to front to size, all the elements will be included here. So for I equals to 0 to I less than rear I plus plus, rear also included in that, printf percentage d slash n cq of I. Okay, I mean whatever the elements present up to the rear only printed. So after the rear what is present, front is present. So I equals to front to I less than size, the remaining elements will be printed as it is. Printf percentage d of slash n and cq of I. Okay, everything looks good. Let's compile. Let me check if there are any mistakes in the code. Enter the element. Okay. Mm, okay. Let's move on. DS circular data structure. It would be a C file. CNQ of rear equals to I element. Okay. What is here? He's saying I element. Okay. I element is fine. CNQ. Okay. Rear equals to 0. Mm, in function CNQ is neither array nor pointer. Scanf percentage ampersand I element. Okay, we have taken the element as correct only, right? Okay, read equals to 0. If read double equals to size minus 1, we have to print read equals to 0 and C N Q. Is NQ correct? C N Q is equals to I element. Okay. Hmm. Rear equals to front equals to 0. Okay, this is also perfect. Then CQ CNQ CNQ. Sorry guys. Okay, the function name is CQs, right? We are not going to insert the elements in our NQ. This function name is CNQ, but we have to insert the elements in our circular queue only, right? Okay, no issues, a small mistake. And then okay, circular queue. Okay, comma, and what is here's mistake? Expected declaration. Okay, we have not given. Okay, that's it. Okay, we are going to insert the element, for example 10. Okay, perfect. Another element we are going to perform 20. Perfect. We are going to insert another element, for example 30. Okay, perfect. Another element 40 and another element 50. Okay, as this is the we have given the size as 5, right? Here we can check. We are okay, hash define size I have given 5, but if you are going to insert one more element, for example I'm giving the element as 60, right? So it will print like a circular queue is full, so we cannot add more elements. So let's display whatever elements present in a queue. So 10, 20, 30, 40 are the elements present in a circular queue. Okay, this is perfect. And let's move on to deletion of our queue. I mean, deletion of queue means whatever the delete which element will be deleted first, or 10 element will be deleted first. Okay, see guys, I mean, front is at the position of 0, right? So because of that, front will be deleted. If you are going to insert another second option, 20 will be deleted, and then another 30 will be deleted, and another one 40, and another one 50. Here there are no elements present in a circular queue, right? So it will print like there are no elements present in a queue. See, no elements in a circular queue. That's it, perfect. If you are going to display no elements in a display, it will simply print as 0. Okay, if you are going to another add insert a element 10, and we are going to display 10. Perfect, our code is running very fine and everything is very good. Let's wrap this meeting then. That's it for circular queue. I'll be making more videos on C++ from tomorrow onwards. With the help of Virtual Studio, I will be making in that video, because Dev C++ isn't supporting the standard temporary libraries still. So after that, I'll be making videos on C++. But up to that, if you like this video, please like. Thank you.